In this new series of videos, I will be reporting on the development and construction of a much-needed micromill, a larger project with potentially many pitfalls and obstacles. I hope you enjoy it. This happens to me so often. I have to drill a hole of 0.5 mm diameter or work with a 2 mm carbide end mill. And then it is quite a struggle with that relatively clumsy big mini mill with a much too low RPMA. Fortunately, it still works well here. But oh, how careful you have to be with the feed rate at such a much too low speed. The 4000 RPM of my FF500 is much too slow for these tasks. 20,000 is more appropriate. This graph plots horizontally the diameter of a high-speed steel milling cutter or drill, and on the y-axis, the corresponding RPM for various materials. As we will see later, this is an important graph when choosing a micro-milling machine. In the graph, the working range of my FF500 mill is now drawn. That range is limited by the spindle speed, which is between 400 and 4000 RPM, and the capacity of the collets, here 0.5 to 13 millimeters. It is clear that my FF500 is not well suited for working with brass, smaller than 5 mm or steel with a diameter under 2 mm. And so this machine is also not suited for the 500,000 or so tiny micro-milling cutters from the Dremel range. So let me look for a micromill that complements my Proxxon as best as possible. This SIG adds nothing and has a worryingly low maximum RPM for such a small machine. Of course, you can't avoid brands like Dremel and Proxxon. However, the Dremels are unsuitable for precise drilling and milling work. This MF70 from Proxxon was designed for just that. But the working range is so limited with 5,000 to 20,000 RPM and 0 to 3.2 mm clamping range that it doesn't have my preference. This spindle from Proxxon has, in contrast to the MF70, a strong brushless motor with high torque at low speeds, but it is really a mystery to me why the lowest speed is at no less than 10,000 RPM. That limits the usability enormously in my opinion. This could be a nice additional work area. Anything between, say, 0.5 mm and 10 mm could be processed properly with such a machine, and the machine would then seamlessly complement my FF500. Here, all machines in a graph. The cutting speeds are given in meters per minute. For carbide drills and mills with their high cutting speed, the picture is somewhat different. Here the UF/E, with its high RPM, is at its best at the really small diameters. But there are more requirements than I have. My wish list is in this table, and it is not modest. I want it all. The SIG is out of the question. With far too low RPM, it is not a real micromill. The Dremel meets almost none of the requirements. There is only a sample drill stand available for it. The MF70 has a cheap motor with far too little power at low speed, and does not meet other requirements like a swivel head either. The UF/E can be supplemented with a column and a cross table, but that ridiculously high minimum speed and the lack of a vertical fine adjustment do not make me enthusiastic. Also, this machine with a column of 20 mm solid steel cannot really be called rigid. It flexes like crazy. And unfortunately, the much more expensive, sturdier combination from Proxxon does not really meet the requirements either. The same motor is used, so the same 10,000 RPM problem. The rigidity has been set by me to average because of a 43 mm hollow tube as a column. This column is about 3 times as flexible as the one planned in my own construction. Finally, the costs. I think I will manage to keep the entire budget for self-construction under €300. Here is a first sketch of what I have in mind. Everything will be made of steel, preferably free-cutting steel. But this is just a first rough draft. During the construction, I will certainly make adjustments and add many details. I will probably also make a few mistakes and have to jump through some hoops. We will see. Let's get started. Cold rolled steel, like this, has the advantage that it is fairly accurate to size, but it is less suitable for machining. We will see why later. For now, it is important that I have at least two reliable reference surfaces, which are completely perpendicular to each other. Of course, this slender milling cutter bends a little, even with very shallow cutting depth. That is why I will later take away 1/10 of a millimeter or so in several passes with a T-slot mill. The material for the column is nicely square and equally thick everywhere, but the surfaces are very slightly convex. The reference surface is made very flat with cross strokes from a good file. This is a simple flatness test. If the reference plane is concave, the column will hinge about one end, and if the plane is convex, it will hinge about the center. If the workpiece is properly flat, it will hinge between these extremes. This looks promising. How do you accurately drill screw holes in a column that is way too long for the mill? Once again, the lathe comes to the rescue. I have a precision furnace that can anneal steel, but these larger pieces won't fit in it. So I'm going to have to get a little creative here. This is the tricky part. That cold rolled steel has been given a lot of tension during rolling. As long as it is not significantly processed afterwards, it does not cause any problems. But especially with significant processing on only one side, the steel will bend and the side where most of the material has been removed will bulge. And with the milling of two 8mm deep dovetails over almost the entire length and on only one side, I can bet on the reference plane being warped. That is why I put the column for the last pass between vices, hopefully, without adding tension to that warped surface. Indeed, that is convex. The steel has risen 45 microns in the middle. But fortunately, the trick of reclamping without tension for the last pass seems to have worked well. The running surfaces of the dovetail are nice and straight. That's it for this time. Next video, I will of course continue with this project. Do you have recommendations, questions, tips, constructive criticism? You are welcome at the comments. And of course you are invited to subscribe. Until next time.